Estimation is the process of getting the wrong answer. Okay, I'm saying that facetiously, but it's one of those things that does have a little bit of truth in it. When we estimate something, we do it knowing that our answer isn't going to be entirely correct. So why would we want to do such a thing? Well, here's the second definition here is a more formal one that kind of speaks to that point. When we have a situation where a completely accurate answer isn't essential, then the goal of estimation is to take a set of numbers and round them somehow in such a way that the calculations we're trying to do become easy. Well, what do we mean by easy? Well, let's take a look at some examples. So suppose we need to buy a set of notebooks, and we have two options. We can buy all 12 individually at $1.58 each, or buy a case for $14. And you're standing in the store and you need to make a quick decision. Now, personally, I can't do 1.58 times 12 in my head. So I'm going to get an estimate by first rounding the numbers. So to do this, I'm going to use the old school method of rounding based on the last digit. In other words, I'm going to round to the closest number. To round 12 to the nearest 10, for example, I have two options. 12 can go down to 10 or up to 20. Well, 12 is 8 units from 20, but just 2 units from 10. Right, so I'm going to go with a closer value and round it down to 10. Now, this is the reasoning behind the round down if the preceding digit is less than 5, or up if it isn't processed, right, that you learned all the way back in elementary school. Right, so what about the $1.58? Should I round it to the nearest tenth, or that would be dimes, or to the nearest dollar? Or how about not at all? Right, what level should I round to is a common question that I get from students, and the answer goes back to our goal of making the calculations easy. I'm going to round each number just as much as I need to get to the point where I can do the calculations, in this case, multiplying them, in my head. Now, I can easily multiply 10 by 158 to get $15.80. So I don't need to go any further. Right? And at this point, I can compare it to the $14 amount and conclude that, yes, the case is going to be cheaper. All right, so how reliable is this result? Well, since I rounded the number down before I did the multiplication, I would expect my answer to underestimate or be lower than the actual value. In other words, the actual cost will probably be even higher. So I'm confident I'm making the right choice, right, by going with the $14 case. Now, I think students can sometimes kind of fixate on the rounding rules that they learned back in elementary school. Right? There are other ways of approaching this kind of question. In this case, for example, I could round the 6 up to 10, then divide that into 200 to get approximately about 20 items each. But remember our goal. Round to make the calculations easier. As a practical matter, I would kind of amend that to round as little as possible to make the calculations easier. Minimizing the amount we round the values is going to minimize how far off our result is from the actual value. So in this case, what I would really like to do is I'm going to take the 6 and round it to 5. Right? That has the advantage of being both close to 6 and being something that I can easily divide into 200 to get 40 as my final result. Notice that that's quite different from 20 and much closer to the exact value. If you get out your calculator, that's 33.3. All right, so when we're talking about estimation, it can be useful kind of after the fact to think about how far off our result was from the actual value. Right? You may not be able to calculate the exact value in a store, right, or on a job site, but you can do it later when you're back at home or in the office. And if estimation is a part of your job, for example, contractors estimating the cost of a job, then this can be a useful way of evaluating how accurate your estimation process is. All right, so there are two methods that we can use to calculate the error. The first is absolute, and the second is relative. Right? The absolute error is just the difference between the estimate and the exact value. Right? The relative error takes the absolute error and divides it by the exact value, which is going to turn it into a percentage. So let's try this out with our notebook example. Our estimate was $15.80, right? But the exact value, if you go to your calculator, would be 12 times $1.58, or $18.96. All right, so let's take those to our formulas, right? That makes the absolute error 18. Whoops, sorry, the estimate comes first. That makes this 1580 minus 1896, which is negative $3.16. So notice how the negative result tells us that we did underestimate. Our estimate was under the actual value. Right, so then to get the relative error, I'll take that value, negative 316, and divide it by the exact value, that's $18.96, and that gives me negative 0.167, rounding it to 3 decimal places, which is usually pretty accurate. Right, now if I really want to make this a percentage, I'll multiply this by 100 and get an error of 16.7%.